How's it going, everybody? In this video, we're going to take a look at our next security topic, which is going to be doing site-to-site VPN. Now, we've talked about this already in a fair amount of detail when it comes to just understanding the theory, but I really want to start putting some rubber to the road and getting some basic operations up and running. So before I actually get into the actual crypto pieces of it, where we actually do phase 1 and phase 2 for IKEv1, we're going to do the initial setup, which is going to be configuring the static routes on all the internet facing edges. So that's going to be CSR2, CSR3, 4, 5, 6, and then ASA1, just so we can point towards our default gateway. So let's go ahead and knock out that real quick. So starting on CSR2, we'll just create a default route to 21.0.0.1. Oh, but how about I put in this second set of zeros and do something like that. Let's grab that line of code and jump over to CSR3, dump that in, and we'll just make this 31.1, and then 4 will be 41, then 5, this will be 51, then 6. We'll get that knocked out real quick, 61. And then ASA1 is a little bit different. We're going to come in here and type in route outside. And we're going to type in 11.0.0.1. Slightly different config, but you get the point. So then we're going to ping 21.0.0.2. Then we're going to ping 31.0.0.3. And then 41.0.0.4, then 51.0.0.5, and then 61.0.0.6. So basically that tells us initially that we have underlay reachability from every node to every other node, which is what we expect to have. So now we're going to jump back over to CSR2, and we're going to begin the configuration of a simple crypto map based IPsec VPN between CSR2 and CSR4. And that'll be the game plan that we have going forward. So that's going to be how we proceed with all the setup. So the way that we're going to start this off is I'm actually going to come in here and I'm going to do a debug. Actually, before I do that, I'm actually going to come in here and do a crypto ISACamp. And there's a number of options and number of configuration options available to us. We're going to be doing just the basic one here, which is going to be the policy, and then we're going to give it a sequence number. The higher the number, the more preferred it is, so we're just going to start out with 10 and hit the enter key. And then underneath here, we're going to specify the encryption is going to be, I'll say, is going to be triple des. The authentication is going to be a pre-shared key. The group is going to be 5 or 1536. The hash is going to be, we'll do a SHA. And then if we look at this, the last piece we have in here is the lifetime. This is actually negotiated, so we don't actually have to configure it. So do show run section crypto so far. That's pretty much all we've got. And we can see that the hashing algorithm is SHA by default. So if we do show run all section crypto, we're going to see that right here that this is the config that we have. We can see that SHA is the default option. So we have that. There's a bunch of other options available to us as well, but for right now, that's where we're at. There's a bunch of other capabilities in here. We're not really going to spend a whole lot of time focusing on this stuff initially. We'll take a look at that stuff down the road as we're going along. So the next step we have is to come in here and create the pre-shared key. So what I'm actually going to do is I'm going to drag this information right here over to CSR4, and I'm going to copy and paste that in, because we want to make sure that they match up. If they don't match up, then there will be problems later on when we start going through phase 1 negotiations. Now back on CSR2, we're going to create the pre-shared key, which is going to be a crypto. Then it's going to be crypto key the crypto ISACAMP key, not the crypto key. The crypto key, and we're going to give it a 0 is going to be what it's going to be set up as. So we're just going to type in here Cisco, and then the address for the host name. We're going to match an address initially because we don't have anything set up right now to do host name based resolution. So we could down the road if we wanted to, but we're going to be taking a look at host name in upcoming videos. So the remote peer IP address in this case is going to be 41.0.0.4, and we're going to hit the enter key. So I'm going to do the same thing on this side, but I'm going to reverse it on CSR4 to be this and just to point to 21.0.0.2. So there's that. The next step we have to do is we have to create the access list that's going to be used in order to match traffic between the endpoints. So in this particular case, I'm going to create, you can do this a couple different ways. What I'm going to do before we actually go to configure this is I'm going to create an access list that matches on 10.1 network and then some of the 172 traffic over here. Because we could match on this connection behind CSR4 for gig 2, which would be the 10.4 network, but we might not be wanting to allow connections directly behind the routers to communicate. We might want LAN segments behind the routers, deep behind the core switches, and deep in the core network to be actually done. That's what we're going to be doing. So we're going to type an IP access list extended, and I'm just going to call this ACL VPN traffic. I'm going to say permit IP from 10.1.0.0, 0.0.255.255 is the source from CSR2 side to 172.24.0.0, 0.0.255.255. So effectively what we're saying is anything coming from the CSR2 side that's coming from 10.1. anything /16 going to 172.24/16, go ahead and permit it. We're going to exit out of that. What I'm going to do now is a do show run section access-list, and I'm going to take this config and I'm going to reverse it on CSR4 side. So I'm going to type this command in, and I'm actually going to grab this config right here. Grab that whole thing real quick. Actually, you know, yeah, I can just grab this like so, and I've got it copied, so I'll just whack this out, and then I'll come back to here. I will paste that information right there, and then I'll grab this information right here. That's been copied now. I'll come back over to here, and then I'll paste it in, and then we're good to go. So now the entire configuration is set up. Get rid of that piece right there. So now if I do show run section access-list, we're going to see that the source traffic is 172.24 going to 10.1 anything. So we're good to go there. Now the next step we have to do, now that we've configured the proxy ACL or the crypto map, or the access list that's going to be called from the crypto map later on, is we actually have to go through and set up the IPsec transform set. Remember just a moment ago we looked at this. We actually have one configured. It's right here. We look at the transform set of default is calling ESP AES and ESP SHA HMAC. We really can't call that unless we don't actually call it itself. So if we want to use just the default transform set, we don't actually have to call it from the crypto map at all. So what I mean by that is if you come in here and type in crypto map and we give it a name. We're going to type in CMAP. We're going to give it an entry. We're going to type in 10, and then we're going to type in IPsec ISACAMP. And then underneath here, we're going to say set the peer to be 41.0.0.4. We're going to match the address to be the access list name, which is going to be ACL_VPN_traffic, and hit the enter key. And then we are good to go. So do show run section crypto. The syntax is as such. So that's as far as we have to take it. if you want to create a crypto, or if you want to create a transform set, and then you want to call it from the crypto map, you can do so. But if you don't call the transform set from the crypto map, it automatically calls the default transform set. So we don't actually have to set one. We're just trying to use as many of the defaults as we can. So we have that. So then I'm just going to come in here and I'm going to grab this set of configuration right here. And I'm going to go over to CSR4. I'm going to exit out of here. And I'm going to copy and paste this in. Now I'm actually going to come up to here. And I'm going to type in no here. And I'm going to set and then come in here .2 and do .21. Do show run section crypto. We can see that we're setting 21.0.0.2. So there we have it. So the next step on CSR2 is to go to interface gig1 and type in crypto map cmap. So we should get an ISACamp message that tells us that ISACamp has been turned on. Same thing with CSR4. Interface gig1 crypto map cmap. Now the next step that we have to go through is actually getting some internal routing to work. So that means on CSR2, we're going to have to go through here and configure some dynamic routing. I'm going to turn EIGRP on both sides. And we're going to type in router EIGRP VPN address family IPv4 autonomous system 100. And then we're just going to type in network of 172.16.1.0, 0.0.0.255. And then do show history. We're going to take these lines of config to CSR3, dump that in there, and then I'm going to go to CSR7 and dump that in here, like so. Do show IP interface brief. We have a few different loopback addresses, so the next thing I'm going to type in here is network of 10.1.0.0, 0.0.255.255. So that will automatically enable EIGRP on these loopback interfaces so that the other routers learn them. So we go to CSR2 and we do show IP route for EIGRP. We're going to see these 10.1.0 networks coming through, which is what we want to see. Now over on CSR4 side, we're going to do a very similar type of setup. We're going to go to CSR4, and one of the reasons why I have the topology set up the way that I do is so that I can use a common set of devices to simulate different networks throughout the entire infrastructure. And one of the things that I'm going to do, I haven't done it yet, but I will in the future, is CSR4 and CSR8 will form an adjacency with each other. So the way that this is going to work is router EIGRP VPN address family IPv4 autonomous system 100, and I'm going to type in network of 10.4.8.0, 0.0.0.255. And then over on CSR8, I'm going to go ahead and router EIGRP VPN address family IPv4 autonomous system 100, but actually VRF S4 for autonomous system 100. And I'm going to type in a network of 10.4.8.0, 0.0.0.255. And I form an adjacency with router 4, do show IP route. You'll notice that nothing shows up in the global routing table. If I do VRF S4, though, I see the 10.4.8 network coming through. If I go to, I have to make sure that I enable it on the 172 network. So if I type in network of 172.24.0.0, 0.0.255.255, and then we'll do 192.168, and we'll do 40. And let me pull this guy out, 255. Do show run interface loopback 40. Yep, that's correct. So do show run section EIGRP. Perfect. Or actually, you know what? I need to modify that network statement. That network statement's a little off. I need to come in here and type in no network statement for that. Then I got to come in here and modify that and get rid of this third octet needs to be a 0. So now if I go back to CSR4 and do show IP route EIGRP, we should see the 192.168 coming through, which is what we want to see. So we have all of the details, all the configuration in place up to this point. Now we have to go through the process of actually triggering traffic. Now, one of the things that we have to do that we haven't done is on CSR2 is I have to go type in, underneath this I have to type in AF interface is going to be gig2 and type in summary address, and I'm just going to set up a default route /0, and I can set up a leak map, but I'm not going to. I'm going to send a default route down to CSR7. So when I look at CSR7 and I do show IP routes, I'm going to see a default route in the routing table to point towards CSR2. On CSR4, same thing. So AF interface is going to be gig2. Summary address is going to be /0. That's going to resynchronize the neighbor adjacency. CSR8 is going to look at that, and now we will have a route VRF S4. We're going to have a default route in the routing table. You need to have that in play, or else there won't be logical traffic to match on for the VPN to kick into play. Because you'll try to reach a destination that you don't have a route in the routing table for. So that's why we need to point towards CSR4 and CSR2 in order to get that. Now I'm going to come over here to CSR2. He will be our guinea pig. And I'm going to do a debug crypto ISACamp and IPsec. And on CSR7, I'm going to jump out of global config and I'm going to do a ping to 172.24.0. What is that IP address on this guy's side? Do show IP interface brief 0.8. So on 7 to be 0.8, and I'm going to hit the enter key. Now, assuming I've done everything correctly, we should be able to form a VPN. Okay, so I sent the traffic CSR2 a whole lot of nothing. So now we have to figure out why it's not working. Show IP route. We do a trace route to 172.24.0.8. Actually, let's do this real quick. Numerically, it gets to router 2. Router 2 doesn't know what to do with it. So router 2 looks at it. If we do a show IP access list, we're not getting any hits. So why is that? We're not even getting phase 1 to start. Oh, you know why? So where am I trying to source from? I'm trying to source from the 172.16 network. I need to say, instead of pinging from that address, I need to source from show IP interface brief loopback 0. Yeah, let's do loopback 0. So we're going to hit do that ping again. But we're going to say source from loopback 0 and see if that'll work. Now it worked. You'll also notice that CSR2 lit up. So we'll give that a second to finish its job, and then we'll walk ourselves through the configuration. Or through, I should say, through the syslog messages in the debug. So that will allow us to understand better what's actually happening here. So phase 2 is complete. We'll do an undebug all. And I'm going to go type no service dash timestamp log and debug. Debugs will be easier to read later on. So let's scroll all the way to the back to the top here. So not a lot happened, but we ended up getting an IPsec match. The key engine message, we have a local traffic that needs to send traffic to the remote side. There's a local proxy 10.1/16 going to the remote proxy of 172.24. The protocol is ESP. The transform set is going to be ESP AES. It's a tunnel mode. The life duration is 3,600 seconds, basically an hour, and we have a lot that size in kilobytes. So we go back and forth now. We have to go and figure out what we're going to do in terms of operations. We found a pre-shared We are not going to do aggressive mode. We're going to try doing main mode. This is something that's dynamically negotiated, so we would have to turn main aggressive mode on in order for it to work. Scroll back up to the top real quick. And then we found a pre-shared key matching 41.0.0.4. We go into main mode 1, and we go through all those little exchanges. We found in the ISACAM profile, we found a matching policy that we're able to work with, and then we move on to main mode message 2, where we start exchanging some other details. We find out this is another iOS box. There is no outside match. His hash, no match. So we're not doing a, it's saying NAT, but there is no NAT enabled. We come down here a little further. We keep going through. We determine that there is no NAT, so we're going to be using UDP port 500. And we continue moving our way down until we get to the IPsec portion a little bit further on down the line. And at this point here, phase 1 is complete, and then we move on to phase 2, which is IPsec. Then we have a local proxy match as well. We know we're in good shape there. There's an attribute match at that point as well. We come down a little bit further, and then we get into IPsec, where we go through the SA transmission, we negotiate the lifetime, all that type of stuff, and the ping at that point from CSR 7 is successful at that point. So we know we're good to go there. And that's pretty much the extent of what we need to know in terms of the operations. So that's how that comes into play. It's pretty straightforward stuff, and it makes it easy to really understand what's actually happening. If we go back to CSR2 and we do a show crypto ISA essay, we're going to see an ISACAM connection set up. If we look at the SA detail, we're going to see that it is a pre-shared key. We're using triple des as the encryption and stuff like that. And you might be wondering, well, hey, I saw in the ISACAM portion that it was ESP AES, and you'd be right, but that's for phase 1. Phase 2 is using triple des. And I'm sorry, phase 1 is using triple des for the encryption, where in phase 2 for the actual data encryption we're using AES. So that's basically how that's coming into play. So one other thing we can do here, and I hadn't planned on doing this, but I'll go ahead and do it anyway. We'll do a capture on gig 1. I'll go ahead and we'll fire off Wireshark. And I'm having yes, I want to understand that. We might not get a feed in here. Every once in a while, I'll get a message from Eve that there was no packets captured, so hopefully this will fix it. Sometimes you'll get this little guy here where it says that they could not add the key, it was not supported or something along those lines. So then I'll just come in here, capture on gig 1 again, and then it'll pop up now, because now we trust the SSL thumbprint from Eve, and we should see some data being sent back and forth here in just a minute when I go back to CSR 7 and then I hit the up arrow. We're going to see some messages going back and forth, and you can see that we see ESP going back and forth. We have no idea what it actually is, right? We see ESP, we see the SPI going back and forth, we see the responses going back and forth, that type of stuff. So we see ESP flows. So for example, in order for me to do this demonstration without a VPN, I would need some sort of connection between CSR2 and CSR4, which I currently don't have. I need like a tunnel or something set up. I will talk about that when we get into things like GRE over IPsec and stuff like that, and how that would come into play, how you'd actually see the GRE header and things like that. So it's good to see the Wireshark capture, because then you can actually see the data is actually being encrypted. You can't tell any of the data other than its SPI value and stuff like that. So that's basically what you need to understand. So I'm going to go ahead and I'm going to minimize this. And what we'll be able to take a look at on 2 is, that's the phase 1 part. If we look at the IPsec essay, we look at this, we can see that we've had a number of packets sent. When we look at this, the local and remote identities, when they show up, we have the address and the mask. Then we have the protocol and the port. So right now, we're just basically saying we're going to just match on anything IP inside of the source of 10.1.0.0/16 and the remote network or networks of 172.24/16 is what that says. We can see that 9 packets have been encrypted and decrypted, so we have mutual communication back and forth. And then if we look at the inbound ESP SA and the outbound ESP SA, we can see those values. And as a matter of fact, they probably line up. If we look here, 389.870, and that's going to be from 870 is going to be inbound, and that would match up because we have 41 going, or some CSR4 going to CSR2. That would be traffic coming into CSR2, and that's where we're looking at that. So we see 870 lines up there, and if we look here at the one above that, we have 405, and 405 lines up there. So that just proves to you that all this stuff is working the way that we're saying it does. So that's pretty much it. Beyond that, there's really not a whole lot more to it than that. We will be taking a look at doing the exact same configuration on CSR5 just to show you what it looks like to have multiple VPN peers. And we'll go through that same process. We won't look at the debugs again, but I'll continue to the Wireshark captures so you'll be able to see how the traffic works. I'm going to slightly modify the config on CSR2 to allow a second entry in the crypto map, so you can have multiple entries. Eventually, I'll have all 4 remote sites set up with crypto maps, and then we'll move over to tunnels with CSR3 to those locations, so you can see how the remote site can do both and stuff like that. So I wanted you guys to see how both the variations come into play. With that being said, everybody, thank you so much for stopping by and hanging out with me in this video. Until next time, take it easy.